Okay, let's take a look at our problem here. I'm assuming that the function is y equals 4 minus x squared. So the x was missing. And so I'm assuming this. So R is the region bounded by this curve about the x-axis where x is between 0 and 2. So let's take a look at an illustration. Okay, I'm going to spin it around the y-axis, and you imagine a shape being carved out of 3D space. All right? Okay. So for the first part, we're going to use a method of disks. Okay. So let's imagine, okay, the shape is kind of like a mound, like a rounded mountain, sort of. Let's imagine that it's made out of coins. Okay. So it's a stack of coins, and the radius of the coin is getting smaller as you get higher until it basically vanishes at the top. Okay. And the width of each coin is the change in y, okay, or dy. Okay. So the radius of each coin, okay, can be measured by the value of x, okay? Whatever the x value is, that's the radius of the coin. So there's an example of one coin at y equals 1, okay? And then we need r squared, so let's write r squared equals x squared. And then, because we're going to do the integration in terms of y, because we're using dy as our change, I want to put x squared in terms of y. That's quite easily done. We just take the function there, rearrange it, and we get x squared equals 4 minus y. Okay, so to get the entire volume, we're going to do a summation. Okay, that's what integration does, of the volume of each coin. Okay, each coin is pi r squared, that's the face, times the width, which is dy. Okay, the y ranges from 0 to 4. So this integration is going to be the sum of all these very, very thin coins. All right. So we have r in terms of y. Sorry, r squared in terms of y. So 4 minus y. And then it's relatively easy integration. We just evaluate it, and you get 8 pi. All right. Let's do it with another method. Let's use the shell method. Okay. Now, the way I imagine the shell method is, let's think of a piece of paper, and you roll it up really tightly, okay? And it so tightly that the radius is nearly 0. This would be the first shell, which goes at x equals 0. The next shell is another piece of paper, slightly shorter, okay? You wrap that around the first one. I'm going to keep wrapping these paper, which are the shells, wrapping around and around and around until we build this shape. Okay, the first one will be the highest one, and the height of these will be diminishing as we go. And the width of the shell, or the paper as we're imagining it, is dx, a change in x. That means we're going to integrate this in terms of x now. Okay, so we're going to sum all these shells from x 0 to 2. So that's from the smallest radius, 0, to the biggest radius of 2. Okay, so think of the paper again. The length of the paper is the circumference of the circle. So 2 pi r, right? That's the length. Then we have the height of the paper. And then we have the width, which is dx. Okay, we sum all these up. This is integration. Okay, and so we have, we need everything in terms of x. First of all, I pulled the 2 pi outside. Okay, we're doing the integration in terms of x, so all the variables have to be x. So r is equal to x, we know that. And then the height of the shell is the value of the function at this particular x. Okay, so that's given by the function, 4 minus x squared. And then we integrate this again. The integration is not a big deal as long as you know how to do it. And very good to see that we get the same answer. Okay, so I like this doing one problem in two different ways. Okay, first of all, of course, you want to match the answer so you get the same answer. And when you do that, that builds confidence. Likewise, if you get a different answer, it really indicates where you have a problem. Okay, so it's good to do, if you can find two methods for doing one problem. I always recommend to students to do that. It's a great way of reinforcing your good work or really flagging any mistakes that you have. Okay, I hope that was helpful. Again, that function I assumed was 4 minus x squared. If your function is different, okay, you can use these same methods, try it out on your function. That would be a good exercise.